All right, this is the second phase presentation for Group 8 for Business Analytics. And this is Shane, and our group members are Lindsay, Quinn, Jonah, and Alex. All right, so the finalized data set we chose was the Spotify Global Music data set. It's a CSV file, it's 1.42 megabytes, has 8,700 rows, 15 columns. It contains 6 columns with numerical data and there is dates and times in the data as seen, and it does not contain geographical data.
And then our second data set that we found um, is global music streaming trends and listener insights. Um, there's 5,000 rows and there's 10 columns. Three contain numerical data. Um, and there are dates and times on this data set. And this one also does include geographical data. It shows like where the listener's from and stuff like that, and their preferred listening time. And yeah.
And here's the problem that we want to address. The music industry, especially streaming platforms like Spotify, have become highly data driven. Artists, producers, and record labels must realize what factors cause a song's popularity to improve their marketing strategies, production decisions, and audience engagement. The problem we want to address using the Spotify data set is what factors impact track popularity. More specifically, we want to analyze in what ways artist characteristics, track attributions, and album features relate to a song going worldwide. Understanding these connections can supply insights into what makes a track successful on a streaming service like Spotify.
So the first visualization that I discovered is a scatter plot, and it displays the relationship between artist popularity, and that's on the bottom, the x-axis, and track popularity on the y. Each circle represents an artist's individual track popularity in the data set. So the size of each circle reflects the total number of followers of that artist. And the scatter plot shows a positive relationship between artist popularity and track popularity because it's going up diagonally. And most data is condensed in the lower left area of the visualization, explaining that the majority of artists have low popularity scores. And as seen in the middle of the plot, I hovered over the middle circle. That's The Weeknd. So he's really popular, but Taylor Swift is like all the way in the top right, the most popular. And it shows in the top right, like kind of a legend of what the ballpark range is of popularity for each of the circles. And then the question that I picked was what combination of artist popularity and artist followers best predicts track popularity? And my process of answering that was finding the outcome of track popularity and using predictors, artist popularity, and followers. And as seen in the slideshow above, I made a scatter plot, and it indicates that since it's pointing all upwards, it's a positive correlation between the two outcomes and predictors. And if points follow a linear line closely, which I did not put on there, but if there was just a line going through, that would just indicate that it's a strong relationship. And then if you compare two scatter plots together and like kind of mixing around which ones are variables and like which ones aren't, so, and you can kind of figure out like which works best for the question. So if ours popularity alone uh, works better, it's like a stronger predictor and vice versa for followers. And if both together improve the prediction, which they do, as shown on the scatter plot, then the combination of both best predicts track popularity.
And then here's the second diagram. I made this one. It's two pie charts, and basically what this shows is the listening time uh, for free and premium subscriptions. With the orange showing who listens in the morning, blue shows who listens in the afternoon, and red shows who listens at night. And this can create a simple presentation of account type based on the listener's preferred listening time. And I chose a pie chart for this, but you could probably use like a histogram or a stack bar chart in this case as well. And the question that I posed, which is sort of related to the diagram, is there a way to predict whether a listener will have a free or premium account based on their listening time? Uh, First, the process of answering this, the first step being identifying the variables. We have the outcome, which is whether the listener has a free or premium account, and the predictors, which would be their preferred listening time, which would be morning, afternoon, or night. Second step, creating a visualization. Like I said, I did a pie chart, but histogram or a stack bar chart could work as well. And then we can compare the differences between the results between free and premium and their listening times. And then the last step for this would be to view the results and see if there's any comparisons between listening time and the account types. If a specific time shows a higher rate based on the account type and a lower for other types, then there may be a relation between different listening times and the listener's account type.
Yes, this is my diagram that I chose. It's a tree map diagram. So as you can see on the far right, it shows artists based on follower counts and popularity in the bigger boxes. And each rectangle represents an individual artist. So like you see Taylor Swift, Weeknd, Ariana Grande, etc. And the larger the rectangle, the more follower base they have, or the more popular that artist is in compared to the rest of them. So artists like Taylor Swift, The Weeknd take up more space on this diagram, so they have a higher listener count and dominate most of this tree map. Um, and then as you go down, artists with the smaller rectangles are artists with less followers comparatively. And so this is a pretty easy diagram to just give you a visual of who has more fan base. And then, yeah, the question I picked was, does having a larger follower base actually influence your track's popularity? So, how I wanted to answer that was first identifying the variables. So, the outcome was track popularity, and then my independent or predictor would be the number of artist followers. And so then I created a tree map diagram to show like a visual of it, but kind of similar to what Shane did. You can also create a scatter plot, which is kind of what he did on the first slide, which would show on the x-axis popularity, or sorry, followers on the x, and then popularity on the y. And then you could draw that trend line to see the correlation and see if there is a positive relationship between followers and overall track popularity. And then, yeah, just viewing the results of that. If artists with higher followers have a higher overall track popularity, then that means the more fans they have, the more likely if they release a song, it'll be more successful. And then vice versa, smaller artists sometimes have higher track popularity, so there could be other factors into it. So like artists that aren't Taylor Swift could still have a song that charts, but that could be based off like other variables that aren't in that graph that you can't see. So like marketing, virality, or the genre of music they pick. So
For my visualization, I did a histogram that shows the number of different age groups that listen to specific genres of music. This visualization can help with providing insights for which genres of music are most popular and genres that are the least popular with each age group. Also, this is important, the visualization takes into account all the different streaming apps, not just Spotify. So if we wanted to view this for only Spotify, we could filter out the other apps included in this histogram. And for my question, I did, how does music genre preference change across different age groups? So for my process of answering this, I started with identifying the variables. So the outcome would be the music genre preference measured by the number of listeners. And then for the predictors would be age group measured in age bins. Secondly, I would build a histogram and assigning age bins to columns and numbers of records to rows, adding genre to the columns, creating separate genre panels, and lastly, viewing the results by comparing within each genre and compare across genres for the same age group. And in this histogram, it is recognizable that younger listeners favor genres such as pop and hip hop. Middle-aged listeners prefer rock, pop, and country, and older listeners prefer rock, classical, and jazz, and more.
This is the fifth diagram. This table shows a list of songs along with their track duration and popularity score. The duration column tells us how long each song is in minutes, while the popularity column shows how popular each song is on a scale that likely goes up to 100. Most of the songs are about 2 to 4 minutes long, which is actually common length for a popular music song. The popularity scores vary widely, ranging around 30 to over 80. From the table, it does not look like longer songs are always more popular or the shorter songs are less popular. Instead, songs of many different lengths can have high or low popularity. Overall, the table suggests that there is no strong relationship between how long a song is and how popular it is. And then my question that I ask is, can we predict a song's popularity based on audio features? Step one would be exploring the data, collect and clean the data set, audio features and popularity, and then removing missing values or adding values that need to be added. And explore relationships using graphs, looking at numbers and possibly seeing patterns. Step two would have a table split into song popularity and audio features, and then have a model with, for example, you can have a regression or a classification model, and then you could use audio features to predict popularity. And step three, evaluate the results. Explore the results on the table, seeing what features make the song popular, and identify which audio features are most important in predicting popularity.